Thank you. I really appreciate the opportunity here, folks. I want to go through some of the topics here. We have a polling question to start. I don't know if somebody can launch the first of those there. Um, just to get a survey for how many folks are running Kubernetes or interested in security here. Obviously, I'm going to be giving a presentation, and we may not have time to get through everything. Certainly going to have some time in the Slack channel afterwards. So feel free to hit me up there or contact me with the information that we have there at the end. Let me share this, and we'll get started. So Kubernetes security, this is Chris, by the way. I'm the Director of Solutions Engineering for a company called StackRox. We're a security company for containers in Kubernetes in Mountain View, California, although I'm in the greater New York City area. So I work directly with clients who are engaging in securing Kubernetes clusters to implement solutions for things like compliance and vulnerability management. But we're going to talk today mostly about things that you can use today that are built-in parts of the tool sets to, one, build better security clusters from the get-go. The cloud providers use this phrase of like security of the cloud. So we're really talking about security of the cluster. If you're using Kubernetes in a cloud provider environment, if you're using one of the platforms that provision Kubernetes clusters for you, whether it's Red Hat or Rancher or some of the many others, all of those systems are built around, about convenience, and they don't always have security as the first goal. So we're going to talk a little bit about, what you're getting yourselves into when you set up a Kubernetes cluster in that way. But then we're going to spend a little bit more time talking about, the applications themselves and the ones that you're using. When you're building a Kubernetes application, or when you have teams that you're leading that are building these applications, you're handing over a lot of the decisions about infrastructure and security to the teams that are actually specifying those deployment configurations. And so we talk about security in the cluster because it's very flexible, it's very powerful, and in some cases, teams aren't making the best decisions when it comes to security. In particular, I've got a personal issue with the way some of the defaults in Kubernetes and the default deployments, again, designed for flexibility, and they're not designed for security. And you may not even be aware that you're kind of accepting these default values. So we're gonna talk about some of those things. So as far as cluster security goes, there are some general overview recommendations that we have here. The most important thing that you really need to think about is understanding what you're getting with the way you've chosen to provision Kubernetes clusters. If, like many folks, I would imagine, you're provisioning them through the cloud provider services. This could be, Microsoft's Azure AKS, it could be Amazon's EKS, Google GKE, or other providers. It could be Rancher, OpenShift from Red Hat. They all provision clusters on virtual machines and on cloud or in premise. They have this model of shared responsibility for security, which means that you've got a portion of this that you're always going to be responsible for. Now, with some of the services, running Kube on cloud instances, you're taking on more of the security responsibility, but that line shifts a little bit when you use one of the managed services. So you need to know where that line is. You need to know clearly that some things are provided for you, like keeping the Kube version up to date, but other things like node security are, mostly still your responsibility. The other thing that we'll talk about is that, the defaults, again, like they're not necessarily the right ones for you. You want to make sure that you're keeping the Kube version up to date, but that also that you're looking at the nodes themselves and you're hardening the node security. And we're going to talk about some potentially controversial recommendations that I might have about how to run nodes in a cloud provider environment. And then lastly, we want to make sure that you're using things that, well, like role-based access control, whether you know it or not, you're using this in Kubernetes today. And we want to make sure that you're using that effectively. So the first recommendation is, of course, just keep your Kubernetes clusters up to date. Nothing like a Kubernetes cluster running an older version with known vulnerabilities in it. Remember that Kubernetes itself is a platform. It has a surface area for attack. We're going to talk a little bit about securing that part of it. But here's an example from Microsoft Azure, and the other cloud providers are similar. This is an easy way to upgrade a cluster in place. So this is very convenient. Please do take advantage of it, or discard your clusters and roll out new ones with the latest versions on it. In general, the cloud providers have a little bit behind the bleeding edge. That's often a good thing, but they maintain the patched versions. They're usually some of the first to roll out these really, the fixes for these really serious issues, because they often get like an early disclosure of those vulnerabilities. So whatever platform you're using, check the version of Kubernetes that you're on and make sure that you are, that you're using the latest of patch versions. Hardening the node security, well, and remember that your nodes are running a platform here. There are special ports for things like kubelet. You should be controlling access. This bottom one, limiting access to the Kube API server, has burned a few companies in prominent ways. It may seem obvious, but again, the cloud providers and other platforms kind of want to do public API endpoints because it's easy, right? You get your kube control, you're running from home, from a coffee shop, maybe when the pandemic winds down. You want to be able to access this from everywhere. So again, designed for flexibility, but that API server is a target for attack, and you need to make sure that it's not publicly available. I mean, we all do it, and I'll admit that I run these occasionally here, but for real production use, even for internal testing, you should make sure that you're not on a public, public-facing network. The other part of hardening node security is, I want you to think about what you're running here, right? You're running something that is dedicated to running Kubernetes. You really don't need a general purpose operating system running general purpose services. And this should go as far, and here's one of my controversial recommendations. You should have very little access yourself. Even if you're provisioning this for your team and you're in charge of infrastructure, you really shouldn't be able to SSH to the nodes. I know for the last decade, we've been provisioning cloud resources and connecting into them for debugging, for monitoring. We really should think about other ways to do that, either through the cloud provider tools or through appropriate monitoring agents and other debugging. Again, the minimal surface area here just means less to go wrong, right? Managing SSH at scale is kind of a nightmare anyway. But we want to make sure that teams can't just arbitrarily get in there. Remember, they get into the node, somebody compromises the node operating system, and all of the pods running on that node are potentially at risk, right? You've got access to the host. So we want to make sure that that access is very, very restricted. To that end, there are Kubernetes specific or container specific operating system images that you should consider if you're not using already. So, either if you're building your own, if you are, you can strip down a regular Linux. A lot of people like to run Ubuntu, but Ubuntu is a general purpose Linux distro. And, we want to be able to restrict it here. So, I would have been recommending CoreOS for this. As everybody probably knows, it's been recently end of life, became part of the Red Hat acquisition. But Flatcar Linux is out as a fork of CoreOS, and this is a good choice. It just runs a minimal amount of software required to run containers and Kubernetes. The last one may also be controversial. I've seen a lot of organizations doing this pretty successfully, but it can get a little bit tough to establish the process. But it's kind of an anti-uptime goal. Instead of patching and maintaining running instances, like SSHing in and doing an apt update, you can drain the pods from these nodes, retire them, remove them from the node using something like cluster auto scaling or like managed node groups in Amazon. Some way of just simply killing off the nodes out of the cluster and replacing them with new ones. That allows the latest version, the newer images for the cloud provider to come in, and so you're constantly cycling through your nodes. Like, you treat the nodes as cattle and throw them away. Don't try to manage them like traditional VM instances. Last thing we'll talk about here, but one of the things you're getting yourself into when it comes to Kubernetes is role-based access control. This is a complicated system. It's better than the original system, this attribute-based access control. But you should understand RBAC, right? It's for users, it's for your developers and administrators and others, but also things like service accounts inside of Kubernetes. And there are roles and cluster roles, right? So things are restricted to namespaces. But because this controls almost everything in Kubernetes that an individual can do or that a pod can do, it's important to maintain some sanity around this. We find a lot of environments, shall remain nameless, that are running a lot of things with cluster admin rights. Now, tools like Helm, at least in version 2 with Tiller, some CI/CD tools legitimately do need the ability to create a lot of things, and they have extensive RBAC privileges. But I see a lot of teams just saying, hey, I'm going to give this cluster admin because, well, because it's easy, right? Because it solves the problem of getting a permission denied on some access that you need to have there. But cluster admin tends to spread in organizations, and you find that a lot of people have access. And if you think about a service account with cluster admin level of privilege, any pod that's tied to that service account now has the ability to impact everything in the cluster, right? So a compromise of that pod, of that application, via some vulnerability path, allows you to do things like delete applications, read secrets, run crypto miners. So there's important visibility here that needs to pay attention to. So there's lots more on Kube security. Our blog covers a lot of these things, specifics for cloud providers. I'll be in the Slack channels afterwards here, track 1. But I'm going to move on. If you have questions, feel free to post them in the Q&A, or I'll be happy to answer them via Slack, or you can get hold of me separately. But we're going to move on now to using Kubernetes, right? Like when you're building an application to run in a Kubernetes cluster, let's assume that Kube cluster is well secured, but now you're properly authenticated, and now you're deploying applications out there. So as a developer, what I would like you to think about is the broader concept of risk, right? What puts your application at risk? Who's going to get in the most trouble when an application is compromised? Now, for a lot of teams, that starts with vulnerability management, which you see at the top here. I'm actually not going to cover this too much today. It's kind of a well-hashed topic. Vulnerabilities are part of parcel. You should know where your images are coming from. You should use one of the really good tools that are out there, or again, the cloud provider services for scanning your images for vulnerabilities. And frankly, you should fix those vulnerabilities. So that's something that should be a part of your process. But process is the key word here, because rather than fixing any one individual vulnerability, it's much more important to establish a process by which, if you're pulling images from public sources, or if you're pulling base images down from providers, that you should be constantly updating those as often as, every build, that the packages, the operating system updates. If you've got a Docker file with an apt update in it, then you should be running that and rebuilding that image from scratch, like every single time, so that you're taking advantage of the fixes that are out there. But vulnerabilities are a way of life, and there's a lot that we can do to pay more attention to certain things. There's a lot of things that we can do to mitigate the risk of a vulnerability being exploited, or if it is exploited, getting further in your environment or accessing sensitive data. For this, we like things like metadata in Kubernetes, like understanding what the difference between a test environment versus another, production environment versus, a staging environment, or how critical the application is. So things like labeling or annotating your applications, keeping them separate into separate namespaces, and then things like minimizing the use of privilege mode, of host mounts, of keeping your secrets stored secretly, right, in an appropriate secrets management solution. And then we're going to talk about things like thinking about network policies to restrict how far an attacker can get in the environment. So, even if you've got your application is free of vulnerabilities as of today, you're going to have a lot of reasons to go looking for, what's running in your current environment and keeping things separate. So we like namespaces for a lot of reasons, right? We recommend that you break your application up, and certainly between multiple applications in a multi-tenant cluster, you should break them up just for sanity and reporting, and sanity and things like kube control results. But stuff like role-based access control and secrets usage is already tied to namespaces. So I know it's tempting, and a lot of application examples out there just assume you're going to jam everything into the default namespace. But it's a really good idea to keep things separate. It's a good way to put a logical segmentation around a namespace. So you should be making use of it. It's one of the top recommendations that we have. And one of the reasons for that is that it allows you to leverage network policies. And so network policies here are the objects in Kubernetes that define really who can talk to who. And these are YAML definitions, just like everything else. Some teams we talk to are aware of them. A lot of them don't really want to be bothered, but it's part of the platform. One gotcha with this is to make sure that in your cluster that the container networking actually supports this. So most of the cloud providers at this point, platform providers, are either putting something like Calico in the clusters or give you an option to run that, or have container networking that enforces these network policies. But since everything else in Kubernetes is built in this declarative way, right? This I want to define the state that I'm seeking. We think security really should be done the same way. That if pod A and pod B can talk to each other and those services are allowed to communicate, then there should be a firewall rule in your network policy definition that explicitly allows that. And all other traffic should be explicitly denied. That's often people groan about having to create these rules, having to troubleshoot them. But it's important for controlling, who has access to that database and how far an attacker can get in the environment. It also, again, it makes it easy to demonstrate that there's a standardized control here. We're going to talk about egress policies too, because there's this, really silly, simple approach to eliminating the likelihood of an attack being successful in your environment just by defining some simple egress policies. Now, the challenge with network policies is they are a little bit complex. In an already running environment with no network policies where everything is just kind of wide open, they can be hard to build. Every team is going to have to take on the responsibility, or you're going to have to dedicate someone who's going to be looking at all of this. But again, like, we think that network policies, right, security as code is important. It makes sure that there's reviews for code changes. If you need to open up a new port or add a new service to your application, that's getting reviewed. And the security policy here, the network policy that would allow that, is being reviewed as part of it. So source code and change control, pull requests, and others is a good way to manage that security change request as well. And because of the nature of security as code here. Another topic is images. You can't have vulnerabilities if the software is not there. So one of the most important things that we can recommend is using really lightweight images, right? These distroless or even scratch images that have virtually nothing on them. So if you don't have that library, you don't have SQLite in there, you don't have apt-get or compilers or something in your images, then there can't be a vulnerability present in them, and an attacker can't use them. So we call a lot of these things are just components that are useful for an attacker, and they shouldn't be, especially in your production applications. Aside from security, this has the benefit of having much smaller images that have less, stuff on them. It makes it easier to be, a little bit more agile when it comes to, tearing them down and transporting them and storing them in your registry. Your cloud costs will thank you. Now, one challenge, of course, everybody's thinking, if you get rid of all this stuff, no shells, no development tools, no network utilities, how to debug things. And right now, still like an alpha stage, one of the things you should take a look at would be ephemeral containers. Now, I really would like to discourage people from having folks log in to anything, and especially in a production environment. If you're under regulatory restrictions, you might actually have a restriction that says you can't do this at all, right? So, not a good idea in general to live debug a production environment. Instead, you should rely on debugging and logging utilities. But if you need to fire up a pod, these ephemeral containers, they're not running continually. And so your application images don't have all of these other utilities on them, but you can have a container in the pod, add it to the existing pod, and then go in and run, these debugging commands or whatever you might need to do. So in an emergency, it's a good solution. There's lots more, and we are short on time here. So we're going to go into some depth here, a slide or two each, on a couple of settings that you should look into, that you should be using. And then a couple more down at the bottom here that, I hope are pretty obvious, but a lot of times, again, the teams aren't aware that these things are going on, don't have an alternative, not sure how much there's risk. The things like environment variables, I see examples like this all the time. Stack Overflow will show you that you can get a database password in to your Kube application by passing it in as an environment variable, but this is just not a good way to pass in secrets. Even down at the bottom, CPU and memory limits are not required in a deployment by default. which means that applications have unfettered access to the resources of the node. Crypto miners love this. Don't give them the opportunity. You should limit the CPU and memory that's available to your pods to really what's necessary. And this is built into Kubernetes, and you should be using it. But let's talk about the three at the top here. A read-only file system. Again, if you're new to cloud native, this seems a little odd. You can't write files to the disk. Why would I set that up? Well, this is immensely powerful. If you imagine an attack, and most attacks these days, these automated, naive malware attacks against applications are looking for a specific vulnerability. They're looking for a specific server. They're probing by sending lots of different content types into your application. But once they're successful and they get a hit, typically they dump a binary to disk, or they run commands that depend on changing the config. There's something that involves the file system. And with a read-only root file system, nobody's going to be able to drop a payload to, /bin or home or wherever. So using the read-only root file system is like this magic trick that you can perform. Check the box, and suddenly nobody can write. You're all probably thinking about the problem with this, of course, is that, well, what if my application writes files? Well, you should be using temp files, like a RAM-based empty directory that will allow you to write temp files, but really you shouldn't be persisting data inside of a container anyway. So, this is that Struts, this is an example of one of those exploits that I just described here. So what we did in a demo environment here is run that Struts vulnerable version from about 3 years ago, and then we sent in an appropriate content type. And the exploit just basically involves running a couple of bash shell commands, right? So first we wget a crypto miner from GitHub. That wget writes the file to disk, obviously. The crypto miner starts up, and it begins to push its results out across the internet. So when we exploit this thing, of course, it just happens. I used to think that this was a little bit of a dated demo, but it's still in 2020 among the top 10 exploited vulnerabilities, right? This particular one. So imagine the same thing here, where I don't have a writable file system, right? So we run exactly the same thing, but that wget command tries to go and retrieve this crypto miner binary and encounters a read-only file system. And so now that action fails, and we no longer have that read-only root file system. We no longer have that miner running here. You can see that when we go in to check what processes are running, just using a PS inside of the container, we just have Java running. We don't have anything else there. There is a cool little utility with Docker. If you diff your running container, you'll get an idea of what's actually changed. So you can kind of get an idea of how close you are to being, read-only root file system compatible. Some other things that teams aren't aware of. Your containers have quite a few capabilities with the Linux kernel, can make system calls, and a lot of these are not necessary. There was an exploit recently involving IPv6 router advertisements that use the net raw capability, and you should be dropping these if possible. The defaults are a little bit over privileged here, and so being able to drop these things prevents in this case changing ownership of a file, right? So in the security context here, you can drop those capabilities and have less that your exploits could accomplish. The last thing I'll point out here for tips and tricks is network policies. So, if I have network policies set up, I can, control the ingress. This is all based on labels, so it's kube native. It's very friendly. This is a lot better than any approach that would involve like writing your own IP tables rules or other proprietary things. And, for egress rules, at least, imagine again that wget here trying to retrieve a crypto miner or other code from GitHub with an egress policy that restricts all outbound access, let's say just for like DNS in your environment. That crypto miner is not getting anywhere. And he's certainly not going to be able to download that software, but they're also not going to be able to contact the other pods in your network. So I know we're running out of time. Sorry to race through it. There's always more, and I can always talk about this topic. So feel free to reach out to me. Check out the StackRox site. Our GitHub repo has some examples of some of these things, some of the code around network policies, for example. And I'll be hanging out on Slack as we conclude here. Thank you.